Hello everyone, my name is Nee, and today we're going to go over the Redux Road project in Core Concepts in Redux. We're creating the beginning of a text-based game using reducers, state, and actions. In this game, players embark in a wagon across distances and can gather supplies or gamble game events and lose it all. We won't create the entire game, but we will set up the foundations of the mechanics. If you've ever played the classic 70s game, Oregon Trail, this should feel familiar. Let's get right into it. So here we have our workspace. In the first set of tasks, we need to define the initial state and reducers. Task 1 is primarily focused on defining an initial state. In our game, the main object is a wagon. This object should hold the main attributes of the wagon's journey, aka the player's progress, like the player's supply, distance traveled, and days that have passed. Therefore, before we do anything, we need to define the initial state of the wagon. In Redux, our state is almost always a plain JS object, so we'll hold it in an object saved to a variable called initial wagon state. So I'll define it right here. I'll do a const initial wagon state equals a JavaScript object. We'll generously start out with 100 units of supplies. So supplies is 100, separated by a comma. Our travelers are now well prepared. Since our wagon hasn't moved anywhere and the game hasn't started, distance and days should be 0. Now that we have the initial state defined for a wagon, we can check off task 1. Since we have the state now, task 2 wants us to define a reducer to manage and update that state. Recall that a reducer receives the state and an action object. For now, we don't really know what changes we'll make to the state yet, so we'll stick to defining an empty reducer. So down here, I could do const. I'll just call it a reducer, and I'll start with the function signature. I'll use an arrow function signature. We're going to make sure that the state is set to initial wagon state in case no state is passed in. And we will pass it an action object. And for now, since we don't know what's going to happen, we're just going to leave it at an empty object. Great. We'll work on filling in this soon enough. For now, we can check off task 2. Task 3 wants us to take the next step and help the reducer decide what the state should be with switch statements. In here, we can add in switch on action.type. We don't know what type of actions there will be quite yet, but we know we can define a default one. So we could do default. And in this one, if it doesn't match any of the other cases, we'll just return the existing state back to us without changing it. This helps us keep our code predictable since we know no matter what, if it doesn't match any of the other cases, the default one will run. With that taken care of, we can check off task 3. Let's move on to task number 4. From task number 4, we can start defining specific cases and action types we want the reducer to handle. First, task 4 wants us to work with the gather case. This is when players are busy gathering supplies for their wagon instead of traveling. So on top of the default one, we can type out the gather case. We'll do case gather. There are a few things that come with gathering. Every time the player gathers supply, they receive 15 additional units to what they have. They do not cover any additional distances since they're busy gathering, but they do spend a day gathering the supply. This means we need to update all 3 values in our state and return it. But in keeping with the Redux principle of never mutating state, we must use the spread operator. We can spread in the old state and override the properties to update it at the bottom. So in here, I'll do return. We'll spread in the old state, and it will update the bottom one. So we'll do supplies, state.supplies plus 15, says it gained 15 additional units. For distance, they don't quite get anything because they're busy gathering. And for days, we'll do state.days, we'll add 1 to that. Cool, that looks pretty good. We can check off task 4. All right, it's time for task number 5. Similar to task 4, we'll add a case where the player is traveling. This action type will be known as travel. When traveling, a player's wagon spends 20 supplies for each day and gains 10 kilometers in distance covered for each day. It also adds a day or however many days they've traveled. We'll start off by defining the case. We'll just put it in between gather and default. We'll do travel. Inside of this case, we want to extract the number of days from the action payload. This will allow the player to travel for more than 1 day each time they do this action. We'll store it into a variable called day, or days, equals action.payload. Cool. Then we'll use the spread operator to update the state. So we could do return. I'll scoot this down a bit. Use the spread operator to grab the old state. Supplies, we'll do state.supplies. We'll lose 20 units per day, so we gotta multiply that by the amount of days. Distance, we'll do state.distance. Whoops. Plus, we'll gain 10 for every number of days they're traveling. And then for days, we'll do state.days plus the days variable. Since we're in the middle of working in this project and we can't quite double check that it's gonna run without any bugs, make sure you check your code for typing errors. But this looks good to me, so we'll check off task 5. I'll scoot my way down to task number 6 here. All right, so in our last action type, we want to account for any situations where the wagon gets tipped over. In a game, this is usually the result of a player choosing a risky action that can give them a reward, such as taking a shortcut across the river to lower travel time, or going across some bumpy roads to find some goodies on the end of that road. We'll call this action type tipped wagon. So down here, I will do case tipped wagon. All right, now we can fill out the inside. So as always, we'll use the spread operator to make sure that we don't mutate the state directly. When the wagon is tipped, we lose 30 units of supplies and we waste a day. We don't have to update the distance traveled since they're wagon tipped. They're not really going anywhere. So we'll do return state supplies state.supplies minus 30, and for the days, state.days plus 1. With that, we've defined 3 separate cases for our reducer, so we can check off task number 6. All right, we can move on to our next task group, play. So in this task group, we're going to simulate a user playing the game. And of course, in a real-life application, we wouldn't have the user make their moves by typing it directly into the code. But for now, we're just testing to see if our reducer works as expected. And if you want to, you could add on stuff after this to make it into a more traditional game. So we'll make ourselves some room down here. I want to kind of leave this whole reducer business on top and just start at the very bottom. We'll start off by calling our reducer and giving it an undefined state and an empty action object, and we'll save it into a variable called wagon. So this will make sure that wagon holds the state. Task 7 wants us specifically to use the let word in our declaration since the state of the wagon changes over time and we want to be able to reassign it. So we'll make sure we use that keyword in our declaration. So we'll name it wagon. And we'll call our reducer, which is just conveniently named reducer, and we'll pass it an undefined as the state. This is because we don't really have any state, and the initial wagon state is just defined here or put here as the default if we're just giving it undefined. Alternatively, you can also just type initial wagon state in here if you want to, but for now I'll stick to undefined, and I'll give it an empty action type. Cool. All right, so we just want to make sure that everything works as expected. We could do console.log wagon and run our code. Awesome. So our initial wagon state looks like we have 100 units of supplies, no distance traveled, and no days. This looks correct to me, so we could check off task 7. On to task number 8. Task number 8 wants us to simulate the player doing the travel action type. And just like earlier, to do this, we'll call the reducer. We'll pass in the wagon state and the action type with travel as the keyword with the payload of 1. The 1 means that we're traveling for only 1 day. So down here, we'll go ahead and do that. So we do wagon equals reducer, and then we just give it wagon again. And then here's the action type object. We'll do travel. And then the payload is 1. For now, we'll just say, hey, can you travel for 1 day, please? And then we'll print it onto the console. And let's make sure that everything looks good. Print. Awesome. So let's take a look and double check again. So for every day that we travel, we should lose 20 units of supplies, which we did. And we gain 10 distances. And days is added, 1 travel day. Awesome. Let's check off task number 8. To task number 9. All right, the next task is to simulate the player doing the gather action type. This should be standard now. We just do the same thing we did earlier. We will go ahead and call the reducer, pass it the wagon state, and the action type gather, and it will save it back into wagon. So we'll do reducer, wagon. This one we do type, gather. We don't have to give it a payload since this one, in the case itself, it does not expect a payload. And that looks good. Go ahead and print it to the console. All right. So in the gather case, we get 15 units of supplies. That looks correct. Distance should be the same because we haven't traveled, and we add an extra day. Awesome. I'm glad this is going pretty well. Let's go ahead and check off task 9. In task 10, we will simulate the player making a risky move, resulting in the wagon tipping over and losing some supplies. This is the tipped wagon action type. So down here, we will call the reducer and pass it wagon. Type is tipped wagon, and then we save it back into the wagon state, and then console.log wagon. Save. Cool. So when we get a tipped wagon, we lose 30 units of supplies, and we add an extra day because they gambled and they did not win. The numbers match up to what we've expected, and we were able to just check all 3 of our action types. So that's pretty good. If on your end you're not getting quite that, I would make sure to double check all of your spelling and double check these curly braces. There's quite a lot of them, so it's kind of easy to kind of just get lost in the sauce. So do that if you're not getting the results that you want. On my end, I will check off task 10. All right, task 11 wants us to simulate a longer travel date. This is kind of a double check on our travel action type. Since we've only traveled for 1 day before, we want to make sure that our code works if the player wants to travel for more than 1 day. So down here, we'll do the same thing. Wagon equals reducer, wagon, and type is travel. We also need to pass it a payload. This time, let's say that the payload is 3 for 3 days. And then let's print, save. Cool. We see now that the supplies is at 5, distance at 40, and days at 6. So there was a 3-day jump from here. And for each day that we traveled, we lost 20. So that's like about 60 units of supplies. but we do gain 10 per day, so that's 10 plus 30 is 40. All right, the numbers check out, so we'll check off task 11. We can move on to our next task group, which has additional things that you could do and some next steps. Task 12 wants us to refactor the code a little bit. So in the game, we want to make sure that the player can only travel if they have enough supplies. If you've messed around with your code so far, you may have noticed that, let's say I want to travel an additional 3 days right here, and I hit save. We can actually go into the negatives for supplies, and then the game just lets us keep traveling as if nothing happens. We don't want this. This is undesirable behavior. So we want to make sure that, again, the player can only travel if they have enough supplies. There's a few ways to do this, but for now, let's just say we can return the current state unchanged if the user does not have enough supplies. So I'm going to scroll back up here and go back to the travel case. All right, so in here, we'll start refactoring. We could take out the new supply calculation, and instead of putting it here, I'm going to just actually cut that. And up here, I'm going to say const new supplies equals, and then I'm going to paste that there. And then we can add an if statement checking if this state or this change puts the supplies in the negatives. And if it does, we just want to return the state. So I will do if new supplies, so the new recalculated supply is less than 0, we'll just return the current state with no changes to days or distance traveled. And for supplies down here, we'll put new supplies so that we take whatever value this is. If it passes the check, we can go ahead and update it down here. So let's test to see if that works. So let's just pretend to say that I traveled an additional 3 days. And it didn't let me because I have no supplies. So it gave me back the exact same state. That looks pretty good to me. I think that's a sufficient way to kind of just stop this behavior for now. As I said, there's many different ways to do it. So you could give the player a suggestion of what they need to do, like would you rather gather supplies instead of traveling? But that's up to you. For now, this looks good. I will check off task 12. We reached the end of the project. Our basic features are now working, and the main project is complete. So make sure to give yourself a pat on the back. If you want some more practice, give the challenges listed in task 13 a try. From here on out, I'll be going over the solution for the challenges as well. If you don't want to do them, go ahead and skip to the end. Now I'll get started. So to add an extra element to Redux Road, we can add a cache property to the state. So with addition to supplies, distance, and days, the player also has a cache value to work with. So up here, at the bottom of days, I'll add cache equals 200. So they get $200, which may or may not be kind of a generous value for back in the days where people were still traveling in wagons. So with the cache, we can also add a sell case that takes away 20 units from supplies and add 5 cash units. So they can sell 20 supplies for just $5. I'll add it down here. We'll do case, sell. So here we could do return, spread the old state, and supplies, I want to say state.supplies minus 20. In addition, I get 5 units of cash. So let's double check that that works. I'm going to just delete this last 2 days of traveling so that we can go back to kind of just having enough supplies to even sell. So we could do wagon equals reducer, wagon type sell. And then we'll do console.log wagon. All right, so we see our cash increased by 5, supplies went down by 20. Awesome, and then nothing happens to distance and days because we just kind of stood there and sold our stuff to whoever walked by, I guess. And then the next one, if we can sell, we can also buy. So we'll do a buy case. And then return, spread the state, supplies. Let's say in this one we get, I believe the instruction says we get 25 supplies, but then we lose 15 cash. I'm not sure if this is such a great deal because we sold 20 for $5, but then if we buy 25, we lose $15. But anyways, let's copy this, paste, and then I'm going to change this to buy. Let's see what's going on here. Cash. Oh, because I'm missing a comma right here. All right, so we gained 25 supplies and we lost 15 cash. Yep, looks good. And then since we have money now, there's the occasional theft. And then, so we'll do return, spread the state. When we get, outlaws steal some of our money, the instruction says that they take half of our cash. Oof, it's a lot. So cash divided by 2. All right, so let's say theft, save. All right. Yeah, that looks like it's half, and then we get to keep our supplies, and then we're still not moving. A lot of things happened on day 3. That looks pretty good. We've added all these extra features, so I'll consider task 13 checked off. And with that, we've reached the end. So congratulations on making it here. With this project, you practice your understanding of Redux's core concepts. You use reducers, state, and actions to create the base logic for a game called Redux Road. Within a reducer, you defined and used action types as strings to represent different actions that can occur in the application. You managed and immutably updated the application state based on dispatched actions, and last, you simulated state changes to test your code in a meaningful way. Overall, this is a great hand-on experience in building scalable and maintainable web applications. So keep exploring, keep building, and most importantly, keep having fun with your code. Happy coding!